In this video, let's have a look at biomass and carbon. We are somewhere in Tanzania with an area of 100 hectares where we grow mango and ficus trees, maize and beans, and where we add compost to the soil. We submit, and we see that indeed our plot is covered by mango, ficus, maize and beans. We quickly check limiting factors. Is everything going all right? Is something significantly restraining production? But it seems to be fine. Also, it is important to be aware of the fact that biomass is produced when plants assimilate CO2 for the photosynthesis process, and for that radiation is an important factor. Show months and we can see how it varies over the months. And this is especially relevant for climates like Europe, where the shortage of radiation can significantly decrease biomass production. Now we can go to biomass. And in this graph you can see above ground and below ground biomass for crops, trees and inputs separately. And here we can see that actually the above ground tree biomass contributes the most to the above ground biomass. Below ground, it's also the trees that contribute most. Then we go to biomass products, so you can see to what extent the different products of crops and trees contribute to total biomass. Then it is also defined specifically for the species and the inputs, so the biomass from, for example, only the ficus tree. And we have biomass product per species. So you can see very specifically, for example, for that ficus tree, the contribution of leaves to total biomass, or roots, for example. Then we go to carbon. The first graph that appears is biomass stock, and for carbon, only perennial species are considered. So our crops are not considered anymore, and we only see mango and ficus. Now, what is the potential of our plot plan to remove CO2 from the atmosphere? We can see CO2 equivalent stock. So over time, we see per perennial species the CO2 equivalent stock above ground and below ground. And if we go to CO2 equivalent pools, we can see below ground and above ground added up to each other. At the carbon removal unit per species, you can see how much carbon is removed by all ficus and all mango trees. And you can see in the beginning of the project, the mango trees were sequestering more than the ficus trees, whilst at the end of the project, it's the other way around. Now, if we want to zoom in on the carbon that is sequestered per individual tree, we go to CO2 equivalence balance per tree. In this graph, you can see the carbon that is sequestered by individual trees of different species. This is calculated by dividing the total carbon sequestered by a species by the number of trees planted of that species. So in this case, we planted 80 mango trees and 200 ficus trees. And we check with forestry how much is actually realized if we go to the number of trees. And here we can see, based on 100 hectares, we have 20,000 ficus trees and 8,000 mango trees. Back to the carbon graphs. So carbon removal unit plots. We see, for example, in year 5, almost 400 ton of CO2 equivalent was sequestered above ground and 86 below ground. For the species specifically in year 5, this was, 147 above ground ficus, 30 below ground, 250 above ground for mango, and 56 below ground. And per tree, this is divided by the number of trees, and we get to CO2 equivalent balance per tree. Now, depending on what's the price of your CO2 equivalent, you get the revenue by species. The CO2 price can be changed in the settings. It's a bit above $20, and if you would change it to 25, we will see revenues going up. Then there is also the CO2 equivalent plot revenue, and it shows the same value only for all species together. Now there is one more thing that we have to look into, which is the situation where trees were already there before the start of the project. So let's say the mango trees were already there for 10 years, and we see the revenues going down. This is because there are fewer carbon removal units, simply because the mango tree is not considered anymore. At CO2 equivalent pools, you can see the carbon sequestered by the mango tree that is part of the baseline. Only the ficus is a result of the project and can be taken into account. Now don't forget that below every graph you can find some more info, and you can export the data both in yearly as well as monthly time steps.